Good day everyone, my name is Mark Christian L. Makilan and this topic established the presentation focus on Program Evaluation and Review Technique or Pert and Critical Path Method or CPM. These techniques are vital components of project management. For the overview of project management is an essential process used to plan, schedule, monitor, and control complex projects across various industries such as construction, manufacturing, engineering, and government. Based on the text, many organizations like Microsoft, General Motors, and even the US Defense Department handles projects involving thousands of activities and millions of dollars. Because these operations are large scale and complicated, they require systematic planning to avoid delays, cost overruns, and scheduling problems. So, project management is an essential systematic process used to plan, schedule, monitor, and control complex projects across numerous industries including construction, manufacturing, and engineering. The necessity for this systematic approach is driven by the sheer scale and complexity of modern operation, like those handled by major corporations and government agencies. Without proper planning, large-scale project risk delays, cost overruns, and scheduling problems. Ultimately, project management ensures efficiency, minimizes waste time and resources, and aims to keep the project on this plan scheduled. So let's proceed to the next slide. Work breakdown structure. The first step in planning any project is to develop a work breakdown structure or WBS. This involves identifying all the individual's activities that must be performed. Each activity can be considered a job or a task that contributes to the overall project. Activities may vary in size and detail and must be completed before others can begin, which creating the WBS. Managers also identify important factors such as the time required for each activity, cost estimates resource required, and the people responsible. Once all activities and relationships are clearly defined, manager can create a complete schedule and timeline for the entire project. So this means the foundation of successful project management begins with the work breakdown structure or WBS, which is the crucial first step where a large complex project is systematically divided into every individual task or activity required for completion. This WBS is not just a checklist, but a logical map that defines precedence relationships, clearly establishing which activities are predecessors that must be finished before subsequent tasks can begin. Once this structure is complete and every dependency and initial time estimate is gathered, the manager chooses the appropriate network technique, which is the PERT or CPM. So let's proceed to the next slide, which is the PERT versus CPM. PERT is described as a probabilistic technique, meaning it considered uncertainty in the time it takes to complete activities. Instead on relying on only one time estimate, PERT uses three: optimistic, most likely, and feministic. This allows manager to estimate the probability of meeting deadlines. In contrast, CPM is deterministic technique, assuming that activity times are known with certainty. This method is more suitable for a project with repetitive or well understood processes such as construction or manufacturing. So this means the fundamentals difference lies in how they handle time. CPM or critical path method is deterministic technique that assume activity times are known with certainty, making it ideal for routine or repetitive project like construction where estimates and reliable. In contrast, PERT or project evaluation and review technique is probabilistic technique used for novel or high risk project because it accounts for uncertainty by requiring three times estimates: optimistic, most likely, and pessimistic. To calculate the expected time and the risk of delay, despite their differing approaches to time estimation, Both techniques shared the goal of creating a project schedule and identifying the critical path, which is the sequence of tasks that determines the shortest possible duration for the entire project. Let's proceed to the six steps of Pert and CPM. First is define the project on all of its significant activities or tasks, or start by clearly defining the project scope and listing all significant activities or tasks that must be performed. Second is develop the relationships among the activities. Decide which activities must precede others, or determine the precedence relationships. This is where you decide which activity must logically precede. Third is the draw the network. Create a visual network diagram that connects all the activities based on their relationships. Fourth is assign time and cost estimate to each activity, or assign the required data to each activity for CPM. This is known time or cost. For PERT, this involves the optimistic, most likely, and pessimistic time estimates. For the fourth is compute the critical path. Calculate the longest time path through the entire network. This path, known as the critical path, represent the minimum time required to complete the project. Any delay to an activity on this path will delay the entire project. Lastly is use the network for control. Finally, use the completed network and critical path analysis as a tool to plan, schedule, monitor, and control the ongoing projects. So let's proceed to the next slide, which is the history of PERT and CPM. Although humans have been planning and managing projects for centuries, advanced project management techniques have only been used widely over the last 50 years. Earlier tools such as the Gantt chart, which used to show activity start and finish times, but they did not provide information about activity dependencies or critical paths. So, advanced project management techniques are relatively recent, becoming widely used only in the last 50 years. Earlier tools like Gantt chart could show start and finish times but lack information about activity independencies and the critical path. So, PERT was developed in 1958 by the US Navy Special Project Office, along with Booz Allen Hamilton and Lockheed Martin, specifically to manage a highly complex Polaris missile program. CPM was developed almost simultaneously in 1957 by researchers at DuPont to manage the construction and maintenance of their chemical plants. Today, both techniques remains essential tools for scheduling and controlling project. So let's proceed to the modeling in the real world. First is defining the problem. Delays in care at the hospital emergency room were causing loss of life and dollars. So here is the core problem was patient care delays in the emergency room. Long wait times and efficient patient flow lead to decreased customer satisfaction, potential medical risk, and overcrowding. The hospital needed a systematic way to identify exactly where the delays were occurring in the complex series of tasks that constitute a patient visit. So second is developing a model. A PERT model was developed to track patients as they move through the various stages of emergency care. So he is to solve this, the hospital management team chose to the PERT model. First, created a WB is to list every single activity a patient goes through, from walking into the ER to being discharged or admitted. Next is the define the precedence relationships. For instance, a patient cannot see the doctor until their initial triage and basic vital signs are taken. This structure was then used to create a network diagram where the nodes represented the patient care activities. Third is acquiring input data, measuring the uncertainty. Since the time for each activity is highly uncertain, the PERT methodology was essential. They use a direct method. Times were recorded with a stopwatch for a sample of patients going through the process. For each activity, this real-world data allowed the analysis to generate three required PERT time estimates. First is optimistic, most likely, and pessimistic. Fourth is developing and testing the solution. The calculation uses these three time estimates. The PERT formulas were used to calculate the expected time for every activity in the ER process to forward and backward passes were they performed on the entire network. Analyzing the result, the PERT model showed completion time of 84.9 minutes and project variance of 253 and 1 seconds or 1 minute. So here is the total project completion time. Expected, the model showed the minimum time required for the patient to complete the entire emergency room process was 84.9 minutes. This is the length of critical path. So the project variance, the variance was calculated as 253.1 minutes. This variance is a measure of the risk certainly that 84 point minutes estimates high variance suggests that while the average time is 84.9 minutes, individual patient experience can differ significantly. Most importantly, the PERT model clearly identified the critical activities of patient care. These activities had zero slack or float, meaning any delay in the specific step would immediately delay the entire patient time in the ER. The analysis also helped point out specific areas of inefficiency, such as the activity of filling out forms, which was likely on or close to the critical path and contributing significantly to the overall time. So lastly is implementing the result or the improvements. Better schedule and control. They could assign more resources to the critical activities to keep them on schedule. Targeted improvements instead of trying to speed up every activity, they focus improvements efforts on the critical ones. For example, they might have moved form filling to the earlier non-critical stages or implemented digital registration to reduce the time of the bottleneck. In summary, the hospital used PERT not to just track time, but to gain management control and reduce uncertainty in their patient service delivery, leading to more efficient operation and better customer or patient satisfaction. So let's proceed to the next slide, which is the drawing the PERT and CPM network. Use activity on node or AON format. Nodes represent activities, arrows show predecessors. Example network includes activities A and H. There are two common techniques for the drawing PERT networks. The first is called activity on node or AON because the node represents the activities. The second is called activity on arc or AOE because the arcs are used to represent the activities. So there are two main methods for visually representing a PERT network. Activity on node. In this method, the nodes are the circle or boxes as you can see in the diagram represent the activities. The arrows or arcs, which is you can see in the diagram, is between the nodes only show the predecessors relationships, which activity come before the next. This is the format recommended by the presentation. So second is the activity on arc or the AOE. In this alternative method, the arcs or the arrows represent the activities. So let's proceed to the activity times. PERT uses three times estimates. First is the optimistic, second is the most likely, and the pessimistic. Used to compute expected time and variance, beta distribution is often applied. So for the optimistic, A means the time required is absolutely everything goes well. Most likely means the realistic duration that is expected to occur most often. And the lastly is pessimistic, means the time required is worst case scenario. These three estimates are used to calculate the expected time and variance for an activity, often applying the statistical approach called the beta distribution. The expected time is often calculated using the formula.
Good day, sir. Good day, classmates. So, continuation is sa kwan sa report topic nga Pert CPM, IP o Pert and CPM. So, ano nga topic 3 is probability of project completion. So, introduction to project completion probability. The critical path analysis help us to determine that the founder's expected project completion time is 15 weeks. Arcade notes, however, that if the project is not completed in 16 weeks, General Foundry will be forced to close by environmental controllers. He is also aware that there is a significant variation in the time estimates for several activities. Variation in activities that are on the critical path can affect overall project completion, possibly delaying it. This one occurrence that works highly considerably. So PERT uses the variance of critical path activities to help determine the variance of the overall project. If the activity times is statistically independent, the project variance is computed by summing the variances of the critical activities. So, parang formula, no? Project variance is equals to summation of variances of. So, ay, sorry. So, ano siyang table lang sa project completion. Kaning, kato ng mga critical activity, which is kaning, which are letter A, C, E, G, and H, na may mga value. So, ano yung mga value niya, no? So, kung ano, ang formula ba sa kung ba ang pag-compute sa project variance is kanang summation sa kaning summation sa mga variances of activity. So, natay project variance nga total of 3.2 na 3.111. So, natay project variance na. So, natay mo na yung kuan kaning yung figure nga. Sa to mo na kanang mga blue na mga kuan, ang mga shaded na mga ano blue nga shaded is kanang kuan na siya. Kaning mo na yung katong mga activities sa critical activities. So A, C, E, G, and H. So we know that the standard deviation is just the square root of the variance. So project standard deviation is equals to square root of project variance. So natay ko under no. Namatay project variance na 3.111. So square root nato. So natay project standard deviation nga 1.76 weeks. So how can this information be used to help answer questions regarding the probability of finishing the project on time? So in addition to assume that the activity times are independent, we assume that the total project completion time follows a normal probability distribution. So it also means that there is a 50% chance that the entire project will be completed in less than the expected 15 weeks, and a 15% chance that it will exceed 15 weeks. So for Harky to find the probability that his project will be finished will be finished on or before the 16-week deadline, he needs to determine the appropriate area under the normal curve. So the standard normal equation can be applied as follows. So, mo siya no? Z-score mo siya atong kano, kaning ang probability. So, Z-score is equals to scheduled time minus expected time over square root of summation of variances squared. So, mo siya no? Para sa siya dala so scheduled time minus expected time over sigma project or sigma project or kuha na siya project project standard deviation. So, ano siya? So, naaman tayo ko na scheduled time nga 16 weeks. So, i-minus na nato 15 weeks nga expected time over sa ato kuan sa ato project standard deviation nga 1.76 weeks. So, we have kuan 0.57. So, amo na to z-score. So, ug ato ba tanawon din sa table sa kuan standard normal distribution. So, a z-score of 0.57 corresponds to a approximation of 71.6% probability that the pollution control equipment can be put in place in 16 weeks or less. So that's all for project completion probability. So let's proceed for using the XLQM for the general foundry example. So ang kanya siya na di lang siya sa normal nga XL mga kuan mabuhat. So kailangan nga nakatong kuan tong add-ins nga ay katong kanang XLQM nga na add-ins nga kanya ba. So ang first step daw na kay kuan kanang sa add-ins daw niya is kanang select nimo ang QM. So select na pod nimo ang after pag-select nimo sa pag-click nimo sa QM is select na pod nimo ang project management from the drop down menu. So man siya diri no. Tapos pag select nimo ana is na kuan na options diri nga kuan kani predecessor list, start, end nodes, brushing, mean, on standard deviation given. So ang imo pilihan na is predecessor list so na diri. So after that kay choose the number of activities and the maximum number of predecessors and select 3 times estimate. Click OK. So, enter the number of activities. Diba ang ato man ito gain na mga activities kay iskuhan. Ilan eh? 1, 3, 4, 5, 6, 7, 8. So, we have 8 activities. So, ato ito lang, matang ibutang dari 8 activities. Tapos, name for rows. So, natay, pambutang name mga kandira ni ito mga letters sa kada row. So, na A, B, to H, but O to H. Tapos, mananong ko ano, sa, galing. Next is kuan, ganing sensitivity analysis and project management. So, dire na sa ng kuan, no? Kanang iyang pagkuan sa XLQM. So, first is kanang, dire nga side, data. So, natay walo ka buok nga activity. So, A to H. Tapos, ang atay pabutan dire, di ba, tulo to ka kuan sa atong last report sa kaning last reporter nga kuan. Kaning A which is kuan, optimistic time. Tapos, kuan, M ba to? O M is most likely nga time nga mo kuan. So, na mo ni siya nga tape, mo ni siya nga kuan, no? Sa mga araw. So, kuan pessimistic which is kanang kuan kanang murag worst case scenario basta nga na. So mo na siya diri nga kuan nga column. So input the 3 time estimates for each activity so mo na siya diri. So na chart diri no which is kuan called Gantt chart. So shows the critical activities and the non-critical activities. So pagkabala na lagay na natay kuan critical activities nga AC, ACE, G ug H. So mo ni siya ang mga kundala ng darkened kon bitaw. Kanang dark kining shaded nga dark siya. Kanya ang kaning mga non-critical activities mo ni sa B, C ug F which is kanang dili kuan shaded darkly. So mo ni. So the results table displays all the activities and their earliest, latest, and slack times. So that's all for sensitivity analysis and project management. Ug manapod do tanan ang kuan kanang tapis sa Pert and CPM. So thank you.